To our live stream today in this Next Generation AI series. I'm Beth Carey, the co-founder and CEO of Pat Inc. If you'd like to be notified of our weekly sessions and updates, please click subscription or subscribe in the YouTube channel below. This session today is called the Universal Dictionary. And to put that in a business context, with a meaning-based NLU, you have one language model for conversational AI and for enterprise knowledge graphs with infinite reusability, but without the training and perpetual retraining. So let's listen to John Ball and watch as he shows us, for the first time that he's done it publicly, a super user view where he'll show you how easy it is to add language or add content and knowledge to the meaning NLU. And you'll see why we say it's the last one that we'll ever need. Thanks, John.
Yeah, and thank you, Beth. It's quite interesting, but one of the things that often gets me into trouble is when I say this is the last one we're ever going to need. I'm referring to Men in Black, and a lot of people think, hey, that's a pretty arrogant statement, the last one we'll ever need. How dare you say that? But it does come from Men in Black. It's funny when, is it Will Smith? It was one of those guys that said it, and there you go. So what we're looking at doing is building a semantic library, so the underpinning meaning for language. And the reason we're doing it is for this reason. Human language can be emulated. We've talked for many years, since the 80s, to say that natural language understanding, or NLU, is impossible. And obviously it's not, because every human starts with the capability of learning their own language or multiple languages and then using them. So brains can do it. No reason machines can't do it as well, provided you get the right science. So the problem is we've had the wrong scientific model for many years. There were good models back in the 1800s. We pivoted to some behaviorist models in the 1900s. Now it's time to flip back hard to meaning-based systems that have syntax mapping to semantics in context and resolving things the way a person can do, or an animal can do for that matter. The biggest scientific breakthrough is the decomposition of parts of speech. What does that mean? Well, there's nouns and verbs and adjectives and adverbs and conjunctions, and there's a whole bunch of standard parts of speech that have been built, and that's great from a behaviorist point of view, because you don't have to worry about the mental representation of these things. The trouble is that it doesn't work. And so today what I'm going to show you is I'm going to add two words, or two words that have inflections, if you like. The word, let's see, genius. So a genius is a person who's smart. But I guess it could apply to robots as well. And the other one is purchase. I'm going to talk about how you can purchase something from someone for some amount of money for somebody else's benefit. So if you think about genius, it's not going to add a whole lot of permutations. Every predicate in the system can potentially use genius as its argument. So maybe there's a few thousand cases. But if you add a predicate, because it can be used in many ways, roughly 1,000 for the word purchase. If you can add 1,000 new words, then the amazing part is you finish up with roughly 10 to the 12 combinations we're adding. So if you said the man purchased the car from the dealer for $1 for his friend, if you think of it as each of those arguments, we'll just look at three. The first argument has 1,000 permutations, 1,000 different people that can do that. The second argument, the thing that you buy, it can be probably large, but let's say it's 1,000. The third one, the person you're buying it from, let's say it's 1,000. So 10 to the 3, 10 to the 6, 10 to the 9. And then let's say there's 1,000 permutations of the word purchase. That's another 3, so that's 10 to the 12. So we're going to do 10 to the 12 combinations by simply adding the content for that. And let me just show you here. If we want to talk about things that are in dictionaries, they were well written in the 1400s with some examples of what words meant. We've pivoted to where we break down each word based on parts of speech, which isn't very helpful because you get lots of duplications. And I'm going to step you through how we go about thinking through what needs to change in the dictionary. Let me take this example of pop. Let me pull this onto the screen here. So this is why words can't just be done based on parts of speech or by the traditional definitions. If you see here, if I do the balloon popped, the meaning here is there's an ingressive change of state, so an instantaneous change of state, and the balloon becomes this pop state, whatever that is, destroyed. But you can use the same word, the cat popped the balloon, and notice here when we hit that, it's exactly the same meaning. The balloon is popping, but in this case we've got the cat causing that to pop. So the causation piece is a separate argument, but underpinning it is exactly the same meaning. And we want to retain the same meaning as much as possible so we don't create our own combinatorial explosion. You can see here that popped means, that's our definition, burst open with a sharp explosive sound. And if I go back to the other example, the balloon popped, you can see exactly the same definition, burst open with a sharp explosive sound. Okay, so that's why we want to get rid of the duplicates. I think when the MIT analysis went forward for why NLU was impossible in the 1980s, 87 or whenever it was, they used the fact that there's these large number of word senses. WordNet formalized that to some degree with 120,000 word senses in its dictionary. But ultimately, it's not the right approach, because you can simplify it a lot if you get experts to do the semantic analysis, not school students looking to get $5 an hour or something. So here's our model: parts of speech, noun, verb, adjective, adverb. I'm just going to show you talk about one example. And notice that nouns and verbs can both be predicates and referents, so that's a bit annoying. And then adjectives and adverbs are predicates. But they're distinctive predicates because you can't interchangeably use them. And so our model just moves to the semantic building blocks, predicate, referent. So here, I sort of discussed it verbally. So if a dealer sells a car to a buyer, notice here that we have a seller that is the one selling goods to. So what I'm saying saying out loud is that seller is somehow related to sold, and we want to capture all of those as part of that predicate definition. The reason we do that is the more we reuse the same meanings, the simpler it is to add content to our system. The dealer sold the car. Let me just see if I got that one here and primed up. Yeah, we've got it. So if we just have a quick look at that, the dealer sold the car to the buyer. You can see the dealer does something which causes the buyer to have the car and the dealer to not have the car. And that's the information that we use in conversation in order to manipulate that. But the dealer is also the seller. And I mean, as an English speaker, you know all of that. Okay, so quick summary. This is the model that we used. You've got words and phrases that represent the language components for any of the world's languages. Those link to word senses. So these were called signs by de Saussure and representamem by Charles Sanders Peirce. Then we've got the word sense that they link to, and interpretants, the term that I used from Peirce. And then we take those word senses and then we combine them in order to produce lossless context. So today we're going to focus on what are the word senses in the semantic library that we're going to add, and then on top of that, what are the signs that we add plus some type of attribute, so we're not losing any of the distinction between one and the other, between one word sense. One word sense is word, sign, and another one's. So what's the breakthrough? Well, to some degree, just refactoring or factoring out parts of speech into their constituent components is a major breakthrough in linguistics. It enables NLU to work. But there's some other tricks that we're going to talk through as we go forward. And the training, what does it look like? Well, it looks like you've just added something to your dictionary. And the benefit of that is it's very human-like, because we can learn words almost instantly that we've never heard before and then start conversing with them instantly as well. So we're going to add a predicate and a referent, and then I'll show you that use in context. So we're going to get into the parts of speech function. you're probably saying, oh, there's more to that. It's not that easy. And that's true. It's not that easy. It's not just parts of speech that draws the big distinction. But for example, if you use the rules-based model plus the predicates and reference, it's still too complex. We have a system. It comes from pattern theory, where pattern theory has only sets and lists to manipulate. So if you have some sort of pattern, a set of things that you're looking for, followed by a set of something else that you're looking for, now you're using sets and lists as pattern theory says. And that's what I talk about when I'm describing a pattern. Not here's a flat image and I'm just going to use that one pattern that can't change. No, I'm going to abstract that and layer it in a hierarchy to make it all work. Patterns are always bidirectional, so what you see is what you can remember. Roughly, not quite perfect, but that's roughly the concept. And people have used syntax in semantic networks as the relationship. So they'll say that this is the subject, there's my verb, there's my object. Obviously, you can't use that model because in syntax, you're using an ambiguous representation. A subject is either, well, we'll just see it here. In this case, we've got a man. The man kissed the dog. The man is the subject. It's the effector of the action. And then you've got the dog was kissed by the man. In that case, the dog that is the subject. So the subject of kissed can't be that. You can do some sort of transformation, but if you simply use the semantic concepts of theme and effector, both active and passive are identical. And one of the things we do when we do our 1,000 tests on things like the purchase class is we take into account all of those and make sure that they are resolved correctly. And the other minor thing that's said ironically, role and reference grammar has been running for 40-something years. It's a very good linguistic model that explains how to go from syntax to semantics and back in context. And pattern theory, which is my brain-based model that I devised in the 80s and 90s, which is now at the core of the system that we're showing. Okay, so why is parts of speech a big problem? Well, if we take this example, the man is running. And we know that running is a noun, right? The running of the race was long. It's a noun in that case, the running. And we also know that it's a verb, as in the man is running. So how can you resolve that in a system that's simply looking at nouns and verbs? And the answer is you can't. And as you get bigger and bigger sentences, you get more and more permutations that are unsolvable. When Google introduced SyntaxNet in 2016, one of their explanations in their article, in their press release, was that if you take a word, a sentence with about 20 words in it, you can get 20,000 possible syntactic structures to determine. And as a result of that, there's your justification for using some sort of model that deals with those permutations, a statistical model. And so whether it's a pure statistical model or a statistical model using artificial neural networks, that's a solution to go through those 20,000 permutations. But a better way is don't start with an ambiguous model based on parts of speech. Start with one based on semantics. And we get ambiguity, but it's usually like 2 or 3 possibilities in a sentence that we work through. I showed this last time. I'll just touch on it. If you have the destruction of the cup was just now, that makes sense because destruction is a predicate and predicates are easily bounded in time and space, so just now. But the lip of the cup was just now makes no sense because a lip is a thing. It's part of the cup. And so the same syntax is either grammatical or not grammatical. We can argue whether it means grammatical or not, but it's certainly not meaningful. It's not a valid English sentence. One of the reasons is this next example. If you see the filling of the cup by John was yesterday, when you fill something, it's a predicate that has arguments. So John caused the cup to be filled, I guess, is a paraphrase of that. And that took place yesterday. Completely valid because filling is a predicate. The bottom of the cup by John was yesterday makes no sense. I'd say non-grammatical, but certainly not meaningful, because a bottom is just a thing, a part of the cup. So you want these things to be bidirectional. You want your model to cater to it, and the part of speech model doesn't do that. And then finally, if we just combine a bunch of those, the running, eating of the popping by the kick was tomorrow. To me, that's just word salad. It's got no meaning whatsoever. But you can have sentences with exactly the same parts of speech that are meaningful. So bottom line is you want to use semantics in context for this whole thing to work properly. There's a bunch of other things that are in the linguistic literature. So you can grab virtually any linguistic article by professors or anybody around the world that's writing on linguistics in any language. If they're using the parts of speech model, which is probably 99% of all the papers written, they get into problems like this, where you've got the word kick, which is both a noun and a verb. You know, the kick at the soccer game was stressful. The man kicked the soccer ball, so noun and verb forms. And what they argue is that kick is basically a verb because it's an action, but you can convert it to a noun with a null inflection. And saddle is a noun because it's a thing, but you can convert it into a verb by, again, a null transformation. And you can see the silliness of this. So basically, kick is a sign. It's a predicate because it's something that you do, but it's also a referent in that the thing kicked can be referred to, the event of kicking can be referred to, and so it's better not to use that model at all. And then you get these types of things, savage, which is a horrendous problem for NLU. If you've got the man is savage, let me just. So here we've got the man is savage, he is savage. The man attacks savagely. The man savaged the enemy. So verb, adverb, noun, adjective. All of those are the use of savage, and yet they have 4 separate definitions. If we look at our system here, I'll just show you how that type of thing is handled. So if we've got one word sense that means savage, and if we skip through, you know, this is super user view here of all our associations. I'm just going to draw your attention to this column here. So these are the word forms that we're customizing. So we've got the word here, savage and savages. We're using that as some sort of referent. We've got savagely here. That's our adverb form, our how form. We've got an attributive form here. This is our the man is savage, as in the adjective form. And then a bunch of verb forms, savaging, savaged, etc. So we put all of those in, and when you look at this, you've got to say, okay, well, that's impossible to manage, and that's why you get back to this test-driven system. Here's a different visual form of the same thing that I just looked at. We need to get into the training because fundamentally that's what this stream is about today. So let's start with that. So what I've got here to prove that the system's working is there's a lot of content and associations that you make with pattern theory and RG linguistics to make NLU work. And you can look at something, and even a super genius can't look at thousands and thousands of different elements that are supposed to work in sequence to get to a result. So what we do is we simply test end to end. You know, if you put in a sentence and get the right result, and you can think of 1,000 permutations of that, we put in 1,000 tests to make sure they all work. So here's our, our way of doing the testing. You can see here, I hope that's not too small, it's just a text file. The man bought a car from the dealer for $1, and then we ask questions: who sold the car, who received the car, who did the man pay for the car. So that's the one that we're going to test first. Then we're going to add the content, and then we're going to look at this one: the genius purchased the car from the dealer, who sold the car, who received the car. So we're using the same system, we're just going to add genius and purchase. So that's an example of the tests. Obviously we would do a lot more tests, but it's pretty good go no go test. And then if we look at the word buy, I just pulled this off our development experience system. It's the system for developers to experience the PAT system. And you can see there's a bunch of things that are available for users to play around with. You know, there's your nice verb form: the man bought the car from the dealer for $1 for Beth. Here's an infinitive: to buy the car was stupid, for the man to buy the car was stupid, those types of things. And we're going to then test that we've added content correctly with the genius purchased the car from the dealer for $1 for Beth. You know, so we've just taken a few of them. I can't run through all of them anyway in the live stream because you've got to get on with things too. So there's our goal. Let's just get to it. If we have a look at one of those files, just just to show where we're going here. If we take the pre-file, I'm just going to run them all.
The man bought a car from the dealer for $1.
So you buy a car from the dealer for $1. Who sold the car? The dealer. Who received the car? The man. Who has sold the car? Has sold the car. Where's that gone? The man.
For the car.
Who was sold the car? The man was. So you can see that the system's simply producing results based on the context that we've added.
Pay Beth for the car.
And this one, did the man pay Beth for the car? No, the dealer. No, the dealer's not a great answer unless you already speak language, but that's
What was the man
what
presented
users
with?
of these systems do. So notice a lot of stuff has happened without much effort. So let's go in, add some content here. So I'm going to just click on add a new word. I'm going to add the word genius, so the meaning of genius, and that's a reference. Don't worry about following all of this in detail because you won't be tested on it later. And I'm just taking here the WordNet dictionary, and I'm going to take one of the definitions to paste into ours, just so we've got a reference. So a genius is someone who has exceptional intellectual ability and originality. Yeah, okay. There's a bunch of duplications there, but we'll work with that. We don't need too much here. We'll just say that it's a person. It's a kind of person, a genius. I don't know if you can have genius dogs and cats, but we're just going with that definition for the moment. So we're making it a hypernym, so it's a kind of. And now we just have to add the word. So I've just added the word sense there, and now we're going to add genius as a word. And basically, depending on the language, we constrain it with some common. Well, we just make our system work. Oops, neuter nouns. A genius is genius or genius. Geniuses, there we go. So at this point, we're ready to rock and roll. We've just added that, and if I validate that, the genius is tall. We're now getting genius is tall recognized here in the system. And genius is R:genius, which is what I'd said, someone who has exceptional intellectual ability and originality. Pretty sure that's what we copied from WordNet, yes. Okay, so that's how complex it is to add a referent. Normally, if you think of it, you would expect Pat or my company, if you were using our system, to provide you with all of the basic components there that make that work. Things like genius and person and cat, dog, etc. Got a question here. I might just respond to that. So you would create a separate entity for the kick value in this phrase, I get a kick out of Beth. Okay, so that's probably, kick out of. It's probably an idiom, so that would be a different sense. And you do a little bit of analysis to say, is kick actually the word there? I got a kicking out of Beth, I got kicked out of Beth. You have to do some analysis. It could just be a literal phrase, or often it can be acting like a verb and have inflected forms as well. So, but that's right, John. That's the right approach to it. Now, what was I doing? So we've just put in genius. If you look at I purchased a car, this one. I was checking, we have the word purchase in the system, but we don't match it because it's not been configured. And I'm going to leave it in there, and I'm just going to add purchase as a separate item for the benefit of showing that we can deal with multiple senses even if we don't use them. Why do I know there's a sense in there? If I go and look at the phrases that we recognize here, you can see I purchased a car is recognized twice, so there's some different syntactic orders there. But these are consolidation sets. These are the syntax that we use to convert to a semantic set. For whatever reason, the semantic set's not being built, so we don't see it. But we will once we do a configuration. And what I'm going to use here is the building block of by. So let me just open another window here and put on my other screen so I can do a bit of transcription. So I'm going to use the sense for by as my template, if I can spell. Third time lucky. So here, acquired by trade. So we've got what looks like a properly configured form. That's good. Just going to put that over on my other screen. And now I'm going to go and configure this. Hope I haven't been missing messages while I've been doing this, because I don't seem to have enough screen space. Okay, so we're going to put in purchase now. So we give it a token that we can rely on, so PURCHASE. So we're calling this a predicate, meaning purchase. It's a predicate category. This is not our final design. This was an intermediate design, this system that I'm using, but you can't have everything when you do a demo. So this will take a bit more configuring than is necessary. The acquisition of something for payment, we can use that as our description. In this case, let's see, how should we configure that? It should be, looks like it doesn't actually matter. We'll say that it's, if you buy something, you receive it, so it's like a change of state. We'll say buy here. And now we've got to put in what are the associations. So if you buy something, what's the thing that you buy? Well, it could be anything. And it might look like it's a bit of labor here to get through all of the configuring, but it's not when you consider we're adding 10 to the 12 combinations. So so the undergo, or the theme of this particular thing, if you purchase something, you can purchase anything. You can purchase people or cars or dogs or atoms, potentially, who knows. So whatever's in our system, we can purchase. But what can do purchasing? It's something that's animated, and that's actually a predicate as well. Doesn't matter, but anything that's animated, a robot, a person, you can imagine a cartoon character. As long as they're animated, they should be able to do the buying. So we're saying that the actor of that is going to be animated. Now the next thing we have to do is specify its class. So we're going to put this in the buy class. Because buy is a class which has all of the phrases already tested. So as long as we have an association to the patterns that are allowed for buy, we're going to be good for the patterns for purchase, because I'm saying it's in the same class. And we're doing that with one association. And it's a hypernym because it's a kind of buying. And for some historical reason that I don't remember, we have a second hypernym, which is transfer. We get something from that, don't remember what. So we'll add that, and we'll just put that in as a hypernym as well. So we've pretty much finished now our configuration. There's one more thing, you'll see it come up when we do our tests, that should also be established. We just have to put in the word forms now. Purchase has been taken, as I said. Let's make it purchase X. So as long as this is unique, we're in good shape. So we're going to say, we're going to add an English word. Don't worry about the fact that I'm using verbs and stuff as descriptions. So one of the things is there's a bunch of word forms in English. Which ones should we have? Well, purchase, purchases, purchasing has no E in it. Purchase, these are not irregular forms. They're just the forms that are valid in English. A future version will just do all of this automatically. The thing is that there's a bunch of different forms that have to be catered to, and there's a question of how much you do at any point in your development. Okay, so at that point we've now finished our configuration of the verb forms. There's one more that we have to do to get our nominal forms, like the purchasing of tickets, the purchase of tickets, which are different nominal forms. And the way we configure those is we create a different object, a little bit ugly, but we're going to call it an event. And we'll call it a reference, because it's not the purchase now, we're talking about the event of purchasing. And we're nearly done here. So because it's an event, it's just acting like a referent. It's got a singular and plural form potentially. So we're going to say that it's got a sense of purchase, because it's the purchase of something relates directly to the predicate purchase. So we're going to make that a hypernym. And it was purchase X. So we're going to make that a hypernym. Let me just make sure I don't forget anything on the other screen. Okay, so we put in a couple of other things just to identify it correctly. So it's an event. And the other thing is we say that it entails purchasing. Just use the system defined. So there it is, purchase X. So it entails that because if you purchase something, it entails purchasing. So all we have to do now is add the word. So there's two words I want to add. You can say the purchase of goods. So we're just going to add that. The purchases of goods potentially is valid. So let's put in that English referent. I'm going to put it in this way so I can get my plural form. Again, this is an internal view of things, so don't get upset about the fact that you can't follow it or you think that the... okay, so that's... this is our way of putting in achievement because we haven't built out the template for it properly. So it's an achievement. Oh, position ls, that's definitely wrong. It's positive ls. Why? I don't know. Positive ls. So that's just saying that we can now say the purchase of goods by somebody. And the other thing we want to add is a word that we'll use the same sense for it. The purchasing. In linguistics, we know that if you purchasing, if you're purchasing something, that's what's called action nominal, and I keep doing that. We'll clean that up. The purchasings of goods, that's called an action nominal. The other one I'm just calling a derived nominal because you're deriving from the predicate referent form of it to refer to it as an event. It's basically the present participle form, and it's still an achievement. Okay, so now we're fully configured and we can do our tests. So if we now go back to our conversation tests, I'm just going to upload one of those files that we looked at. So this is our post test. The genius purchased a car from the dealer for $1. So I'll just run the first one.
The genius purchased a car from the dealer for $1.
So now we can step through. So who sold the car? The dealer. So notice we don't have sell in what we just added, but we're able to interact because it's a type of buying. We've got our selectional restrictions established. So we should get all the right answers. Well, we will because it's the same class. Who received the car? The genius. Who did the man pay for the car? We don't know if the man paid for a car. It was a genius, wasn't it? So let's just put that in. Who did the genius pay for the car? The dealer. Who sold the car? The genius was. So you can see, wasn't the man. So it's now working correctly. And the other test that I said we do is we would do the comparison. Let's clear that. We'll do the comparison between the buying examples and the purchase samples. So now we've got a bunch of these. The genius purchased the car from the dealer for $1 for Beth. So the genius does something which causes the genius to have the car and the dealer to not have the car, and the dealer has the money and the genius doesn't have the money. So that's exactly what you expect the system to do when it's breaking it down. I should say too, if we go back to the conversation, the magic under the covers here, if we look at the sentence which was the genius purchased a car from the dealer for $1, you can notice that we've got that transfer being recorded specifically on top of the meaning of that one sentence, because that's what purchase means. Okay, I might take a break at that point. Look at the screen. Okay, so Gregory, when you configure purchase as a hypernym of buy, is this how you declare a synonym, or would it equally be valid to declare purchase as a hypernym of buy? In other words, to what extent is the construction important? So the construction is very important, and I'll show you some dictionary definitions in a moment that clarify this. if you bundle a synonym in, it really has to be a synonym, and almost all words aren't quite synonyms. They're close. So purchase is using the same same selectional restrictions. Its arguments have to be the same as buy, and so you could almost say that that's a synonym. But I think you'll find that there's examples in a dictionary where it doesn't quite work that way. So if you take WordNet, for example, which uses syn sets, so synonym sets, I don't like them because you just get too many conflicts where it's not really a synonym. You might as well work off a common hypernym, a common kind, and simply build off that. And so that would be my answer. We have got a lot of experience in what doesn't work. You know, as people say, Thomas Edison worked out 1,000 ways not to build a light bulb. We worked out many thousands of ways not to build NLU at multiple different levels. So thanks, Gregory. LinkedIn. What does the conversational exchange look like between the user, the chatbot, and the dictionary? Well, I guess we're not showing a chatbot exactly. We're showing the conversation engine that's running. So in this conversation engine here, if you think of, and this isn't a great setup to answer your question, but think of the context being loaded by your system. So you call the call center, we put in a bunch of facts as this context, which then loads it into that context view. All of that's being resolved by the dictionary, getting the word the predicate and referent definitions, finding out what's the correct interpretation, and then storing them in context. So that's the super knowledge graph concept, lossless representation of that. Then when a user in the chatbot asks a question like, who sold the car, the system is automating the response to that because it has its context, and it can either say, I don't know, or it was this, or, as you can see here in our chatbot example. So it is quite integrated, and we'll probably do some deep dives into the minutiae of each of those, but that's the chatbot interaction. And what you've seen is that, for example, the word purchase, here coming from the dictionary, has been used to recognize the sentence, which generates the meaning representation, the semantic representation, which then answers the question through the conversation engine. In fact, let's have a quick look at some dictionary entries here, if I can find it on my screen. Yeah. This is some old stuff. So when I started working in 2006 on this project full time, can we make that any bigger? Let's see. Yeah. So these are WordNet definitions. Here we've got a noun, savage. I was interested in savage. And so WordNet has savage or barbarian as a member of uncivilized people. There's your sin set. Savage means barbarian. And then you've got beast, wolf, savage, brute, wildcat, a cruelly rapacious person. But you would use them as she is a savage, he is a savage, she is a beast, or she is a savage. So they can be used interchangeably. And sometimes the synonyms make sense, sometimes they don't. Let's see. So if it's a member of an uncivilized people, like say, I don't know, the Germanic people during Roman days, you would say he is a barbarian. But you could also say he is a brute, referring to the type of person. And what I would think is when you start analyzing today's dictionaries, you can merge those two ideas together. Because if you're a savage, you're both a cruel person and an uncivilized person. That's the message that you get from it. And then we look at verb. It's got a couple of definitions: attacking brutally and fiercely, and criticizing. And the observation that you can make is when you look at a lot of these duplicate definitions, what they do is they take the argument and they put meaning onto the argument, and that gives you two definitions. So what we want to do is have one sense, like if savage is being brutal, attacking brutally, well, if you're attacking the new president brutally, the press, that doesn't mean you're physically attacking, you're, what do they say here, criticizing. It's the same concept, and if you have one and interpret it correctly, you're reducing the number of synonyms, you're reducing the number of senses, and you're still providing very accurate interpretations. And then we've got, let's see, 3 adjective forms. So that was savage. You can look at things like a different word, active. The definitions just aren't that good. So active agent, chemical agent capable of activity. It's not a valid synonym. So if you said the chlorine is an active agent, that's the correct definition. The chlorine is inactive is not English. So active there is not a noun form. It's a predicate. It's an attributive form. It's an adjective form. So the definition's wrong here in WordNet. And one of the opportunities we have is we can go through and clean up all of WordNet, or we can simply build a new dictionary. I think the best thing going forward is for Pat and others to build this meaning repository, which is properly set up for multiple languages, and then get an English form that connects to it, a German form that connects to it, a Mandarin form that connects to it, and just keep developing each of those independently, the languages working on the one meaning repository. And then the meaning repository is effectively doing what WordNet does, but doing it in a very general way. John O'Gorman. His purchase of the Cliff's Edge was tenuous. Yeah, so in that case, you're holding on. You're holding on to the Cliff's Edge. And one of the things I pride myself on is having access to some really great linguists, both semanticists, Van Vellen, the ROG founder, and they can do that sort of analysis for me. I'm just the mere cognitive scientist. But I would say, yeah, you're probably right there, that if you're holding purchase to the Cliff's Edge, that sounds like a different interpretation. Sort of like take. You know, if you take something from someone, you're getting possession. If you take something to someone, you're carrying it to them. So there's definitely more than one word sense at first glance, but you know, maybe there's not as many as we think. And I just like to get down from the Google form of there's 20,000 syntactic structures to work through for 20 words in a sentence to there's 3 possible meaningful interpretations, and in context there's 1. Gregory, do the words used in definitions descriptions link back to their own definitions descriptions? It appears as if any word can be used regardless of it having a definition. Is that correct? No, if we don't have the word in the system, it has, you don't know anything about it. You actually have to learn like a person would learn. So I think you're saying, let's see, there's 2 parts to this. If the words used in definitions link to their own, yeah, so you've got a word linking to perhaps a hypernym, and that will have its own definition. So like person, let's show, not describe. So if we take genius that we added, genius. So if we look at the definition of genius, someone who has exceptional ability, and we gave it a hypernym of person. So if we now select person, you can see it's got a hypernym of anyone, but you can see person and people are its words. So in order to describe in English to somebody, you can say a genius is a person, because we have person here, and that's why the system's designed so that if you have your semantic network set up correctly, this semantic library that we talked about today, if that's set up correctly, you can then generate in the source language a definition for any of these meanings. I mean, we looked at the hypernym one. There's obviously meronyms, which are the have possessions, and then there's also the selectional restrictions, like, you know, it's the actor is this, the undergoer is that. I mean, in ROG, the numbers of those associations is small. I think there was a second part to the question. So one is we are able to link bidirectionally between the hypernyms and the word itself. It appears as if any word can be used. Oh, yeah. So if we have an example of something that isn't in the system, let's just go to the meaning engine. So if I thought genii was the English word for something, we simply at this point say I don't have the word genii. A different version of our system that's just the pure scientific one would still give you the results of everything else in the sentence, because we've designed this thing to be NLU, so we want to be able to track some sort of very noisy channel coming in from somebody speaking, and if there's blocks of things that you can't understand, we still want to give the best result for the rest of the sentence. But this one, because it's the developer experience system, if we don't know a word, we just give an error message back so that somebody doesn't think that more was recognized than actually was. So the last example of the dictionary challenge today is we want to make our dictionary full of these predicates and their associations. So the common parts that make language work, we want to take all of that work away from a developer so the developer can focus on putting in their context and having the system give the correct answers. There's obviously going to be a need for a webhook that goes and extracts database information from a legacy system. But here, we've got eat and feed, for example, are two senses that you can have. Feed in role and reference grammar is cause to eat. And then you've got these other words that are really very tightly coupled to eat. So edible is something you can eat, or eatable is also valid, apparently. Food is something that you can eat. And this is where there's another distinction that comes from what the arguments are. So if you say, my dog eats dog food, you think, yeah, that's fine. Dog food is something that is eaten. But if you said, Sally ate dog food, and you're assuming Sally there's a person, it's kind of disgusting, because you would imagine that Sally eating dog food's gross for a person, but for a dog it's fine. You know, eating cat food, it's gross for a person, but fine for a cat. So these have their own restrictions, but there's no reason the system can't cater to all of those without multiplying out in a combinatorial explosion all of the types of things. And it comes from the context model. It comes from the super knowledge graph ability to learn based on experience. So eats is another word like food. Meal, you know, he ate a meal. Meal is referring to a bunch of things. It's a set of things. And an eater is the thing that eats. So if you then, the point of this was to critique WordNet. Eat here, verb has 6 senses. So eat is take in solid food, eating a banana. So that's the so-called transitive form. Eat a meal, take a meal. We did not eat until, so it's not being specified, but you're assuming that a meal was eaten. Well, why? Because that's what eat means. So we can get rid of one of those definitions and replace it with one. And then here, feed, take in food used of animals only. So the dog was fed food. It fails because you can feed children, because feed means cause to eat. So once you start taking out these additional definitions, you go from a massive combinatorial explosion that's hard to deal with to a few, something in what pattern theory calls link set intersection, where you simply get your predicate, you do your intersection with the referent, and you finish up with something that's usually quite narrow and consistent. I'll just show you 2 more examples here. So if you eat something, you can eat it up like resources or materials. This car consumes a lot of gas. In that case, it's still eat, in that it's taking something, your meal, and it's reducing it. So you're consuming it. So that's part of the normal eat. But when a person does it, the argument, we bite, chew, and swallow. When a car does it, it's simply the same concept as swallow. So again, by decomposing these into a list or a set of things, you can use the one definition and simply intersect or disambiguate it correctly in real time. And then let's see, what's eating on you? How about this one? Corrode. Caused to deteriorate. So the acid corroded the metal, or the wind ate the mountain. There's different ones, but it's basically if eat means a bunch of things, you finish up with, by disambiguating it correctly based on its arguments, you have the right definition. I think there's another message coming up here. From LinkedIn. In general, how complex and time-consuming would it be to model a multi-product frontline agent dictionary? Well, that's beautiful language, because multi-product frontline agent is like a very complex structure. And of course, I'm only laughing because I think of, I'm thinking about what the system's doing here at the moment. So when we did the analysis with a corporate looking at a large inventory of things, if we're providing the basic language features for, say, English, and then you're talking to, say, Apple, and Apple have an iPhone 1, 2, 3, and iPhone X, X1, X2, X3. All of those product names can be batch loaded into the system. They have a common hypernym, which it's a type of iPhone, which is a type of mobile phone, which is the type of phone. So all of that can be done just through a batch load. And then the interactions are almost always going to be coming straight from English. So the English build for one customer is comparable to building for all customers because the native language part is being done once. And I can't stress enough that by getting the basics right and testing it so that it works, as you're adding more, and then as you're adding more content, you finish up with a working system every time, and it reduces then the startup time for any of these projects. So in general, I think, when we were talking about building the system up from scratch, we were looking at a 9-month type of delay. So it's quite conceivable that in less time than that, depending on the complexity of the use case, it's quite doable. I think that's all I had to do here. I'm not sure if I covered the nominal forms here of in my example of purchase. Let me just go back to that. Hate for you to miss out on something. So when we, I showed you the first example and then I got distracted. So if you purchase a car from a dealer, that's the traditional verb form. But we do stuff like this. The purchasing of the car by the man was silly. This one won't work, but I'll show you how we fix it. The purchasing of the car by the man was silly. So notice here, we don't get the was silly part, but we get the fact that the man causes him to have the car. That's sort of the shortened form of semantic representation. So what we want is the silly part because that's the rest of the sentence. And it's because we enforce selectional restrictions, because the purchasing of the car by the man was tall would be using the same part of speech, but that would be meaningless, but silly is meaningful. So if we go here to our sense, normally you'll aggregate these. So if we look at the word silly and we put in the appropriate selectional restriction, which is we want purchase to be something that can be sillier. So, predicates determine arguments. So purchase X is a type of undergoer that attributive forms can have. So when we go back to the meaning engine here, the purchasing of the car by the man was silly. Was that the example I had? Maybe that's a different one. But you can see here that now we've got silly being recognized as what that whole phrase means. And then when we select the whole phrase, you've got the man causes the man to have the car, which is what purchase is saying. Obviously, there's some other inferences that you can draw from it, but that's fine for that particular sentence because the inference isn't in the sentence. If we had it in there, you'd see it. And so this one, the purchasing of the car, that one's called the action nominal, and the purchase of the car, the man's purchase, this one's called a derived nominal, where purchase is being converted into its nominal form, its phrase form. And so the man's purchase of the car is still being resolved exactly the same way. So the Roland reference grammar linking algorithm, as long as it knows what its syntactic arguments are, maps it to the correct semantic arguments, which is pretty cool. I was planning to do that myself once, and I knew that would take me 30 years. So it's really nice that Van and the academics have solved that problem for us. And purchasing the car by the genius was silly. So in this case, purchasing the car, this is what's called the gerund form. Again, the genius causes the genius to have the car. So all of that stuff is what linguistics brings to the table. And that's why I'm very excited about us bringing that now to the scientific community and therefore the business community to leverage in all sorts of applications. So this was the question. I think Gregory was the one that asked it. So how would you go about deploying this? Or no, it was a LinkedIn user. How would you go about deploying this in general? And we've already proven that the things I've just shown you are not hard to do. There's a big project to get the dictionary signs set up for the world's languages. So English we're working through at the moment, but if you want German, Mandarin, Spanish, Portuguese, you need a team of native speakers that can add the signs and connect it to our meaning repository, the semantic library that we discussed today. And I think the right way for us to do this is to effectively open source. We want everybody to be given access to this so that it can become the single source of truth. We're doing this thing once, and then the whole world is able to access NLU with a very mature starting point. And in fact, the starting point gets more mature as we get further down the track and we start adding context repositories which give background knowledge for all sorts of types of dialogues that people have, probably politics and science and, you name it. As usual, there'll be a bunch of references that we show in the description panel at the end. Oh, maybe I won't put that there. That's probably a bit hard to look at. Right, so I think that's all I wanted to cover today. We're pretty much up to the allotment of time as well. If there's no more questions, then we'll either hear from Beth as our moderator, or we'll just wrap it up for today. Okay. Look, thanks everybody for coming. If there's any questions that you've got, please put them in the YouTube comments or ask in LinkedIn. Thanks very much for joining us today. It's John Ball signing off. Bye for now.